recording. Cool. Hey guys, we chose problem 4, so I'll just read it out to you. Inspector Brisbane is called to a crime scene in Hotel 202 and she discovers a crime scene with a corpse. Inspector Brizza starts her investigation and makes the following notes. All the windows and doors are closed in the hotel room where the corpse was found. The air conditioner was running steadily at 21 degrees Celsius. The temperature of the corpse was 27 degrees Celsius when Brizza found the corpse at midnight. The temperature of the corpse was 25 degrees when Brizza finished her investigation at 2 a.m. Use the above observations and Newton's law of cooling to estimate the time of death of the corpse. Assume that the temperature of a living person is 37 degrees Celsius. Okay, so firstly, let's state all the information that we know from the problem. So number 1, we have S, or temperature of surrounding. Is 21 degrees Celsius. We have temperature at time 0, so when the person died, is 37, because we're assuming that they are the normal temperature of a person. Third point is the temperature at midnight, which I'm calling TM. So TM is the number of hours after death at midnight. And that is 27. And our fourth piece of information is that 2 hours after that, or 2 a.m., the temperature of the dead person is 25 degrees. Okay, let's get into it. Newton's law states that the difference of temperature with respect to time is proportional to the difference between the temperature of the body and the temperature of the surroundings. So this means that d big T, d small t equals k t take s. So if we want to solve this to find an equation in terms of big T, we would flip it. So d small t in terms of big T. And then we integrate with respect to big T. So 1 on k t take s with respect to big T equals 1 on k, as this is just a constant, we don't really need to worry about integrating that, and then ln of t take s plus c, which we should always remember. And now for the next problem, wait. I'm just going to chuck this all in brackets just to make it easier. So we'll multiply by the k and take the c across. And then use our log laws to remember that t take s is now equal to e to the kt take c. And we can take this s across to give us a general function for temperature in terms of time. So e to the kt by e to the negative c, which is going to end up being a constant here, plus s, which is the temperature of surrounding. So our first piece of information is going to come in useful. So first piece of information up here is temperature of surrounding is 21 degrees. So T equals e to the kt, e to the negative c plus 21. Okay, so now we use our second piece of information, remembering that t at time equals 0 equals 37. Therefore, 37 equals e to the k of 0, which is our time variable, e to the negative c plus 21 equals 37 there. Rearranging, this is going to become e to the 0, which is 1. that's going to come across and make 16 equals e to the negative c. So we can put this back into our function here, and now temperature as a function of time is equal to 16 e to the kt plus 21. We'll come up here using our third piece of information, which is temperature at midnight, or number of hours after death at midnight, equals 27, which means 27 equals 16 using the formula we now have. 16 e to the k by time midnight plus 21. This can come across 6, 16, etc. Dividing through by the 16 here, simplifying. And now we can take the log of both sides. So natural log of 3/8 equals the power of the exponential here. And we can rearrange to find that Tm equals 1 on k ln 3 on 8. Now this might not seem that helpful because we don't know what k is, but we have one extra piece of information that can help us find k, which will tell us the number of hours after death at midnight. So we'll use our fourth piece of information, which is temperature at 2 AM equals 25. 25 equals 16 e to the k, Tm plus 2 plus 21. Bring the 21 across, sorry, making 4, 16 e to the k, Tm plus 2. Oh no, we don't need to worry about the 21, sorry, I've already taken that across. So we can use our log laws again to remember that the k multiplies through and that it splits into both these powers, and here we have e to the k Tm, and here we know that e to the k Tm equals 3 on 8. So we have 4 equals 16 by our new value of e to the k Tm, which is 3 on 8, by e to the 2k. And now 16 by 3/8 is 6. And then we bring this whole thing across, which is 6 to the 4 under the 4, so it's going to be 2 on 3 equals e to the 2k. Taking the log of both sides, we know that the log of 2 on 3 equals 2k, and therefore k equals the log of 2 on 3 over 2. That's the time. Wait, no, lol, that's k. Ignore me. So now we can use this, recalling that Tm equals 1 on k ln 3 on 8. Subbing our new k value in, 1 on this big number here, which is 2 by ln 3 on 8 on ln 2 on 3, which is approximately 4.84, which means that the person died 4.84 hours before midnight, or time of death is approximately 1909:43. Thanks.